Welcome to our last chapter in 1050. This is chapter 7. In chapter 7, we will be talking about sequences and series. In 7.1, we'll talk about sequences. In 7.2, we'll talk about series. And in 7.3, we'll apply everything we've learned in a slightly new way. So, to focus on sequences today, let's start with some basic definitions. First off, what is a sequence? A sequence is an ordered collecting of events or numbers. So basically, a list of numbers that are in a specific order. Like this one, 1, 3, 6, 10, 15. That's a list of numbers and they're in a specific order that forms a pattern. You'll notice the pattern is adding 2, adding 3, adding 4, adding 5. So there's a specific pattern to this list of numbers, to this ordering of numbers. Now, each number in the sequence is called a term. So we would say this is the first term, this is the second term, this is the third term, fourth term, fifth term, that sort of a thing. So we'd usually list it kind of like this, kind of like a T-table, where on the left is what term it is. So first term, second term, third term, fourth term, on and on and on. And on the right is the number that goes with that term. So 1, 3, 6, 10, 15, on and on and on. That's usually how we write it, so then we can see the second term is 3, the fourth term is 10, that sort of a thing. Now, one other thing, we will be dealing with some infinite sequences. Anytime it has a little dot, dot, dot at the end, that means it's an infinite sequence. Meaning that the sequence just continues indefinitely, forever and ever and ever. Now, the thing we're going to practice first with these sequences is I have 9 different examples here. I want you to pause the video, look through these examples, and see if you can find the pattern in these examples. It's not always adding, it's not always multiplying or dividing. There's lots of different patterns here in these examples. So let me show you this first one. Example 1a is one of my personal favorite sequences. It's the Fibonacci sequence. And one of the harder ones to see. To get the next term, you add the 2 previous terms. So 1 plus 1 gives me 2. And then 1 plus 2 gives me 3. And then 2 plus 3 gives me 5. 3 plus 5 gives me 8. So you add the 2 previous terms to get to the next one. And that's what we call the Fibonacci sequence. So I would say for this description, add the 2 previous terms. Then I want you to list the next 2 terms. So if I add these 2 previous ones, that gives me that my next term is 55. And then I add 55 and 34, which gives me my next term is 89. And on and on and on. So that's what I would like you to do with each of these sequences. Describe the pattern and find the next 2 terms in the sequence. Try the rest of these sequences, the rest of these 8, and then come back and let's see if we found the patterns the same. Let's see how you did. This one I described it as we're adding an increasing number. So 2, 3, 4, 5. There's my next 2 terms. Here I described it as we're adding an increasing odd number. 3, 5, 7, 9. And those are my next 2 terms. This one we're just adding 3 over and over. So my next 2 terms are there. Here we're dividing by 2. So those are my next 2 terms. One other little note, instead of dividing by 2, you also could have said we multiplied by 1/2, which will become important later in today's lesson. Usually we prefer to multiply by a fraction for sequences rather than dividing. Next one, we minused 5, got that. Then we multiplied by 2/3. That might have been a little bit of a trickier one to get. There's my next 2 terms. This one, there's a couple different ways to describe the pattern. This is the best way I've found, but you do it however makes the most sense to you. I added 1 to the numerator and denominator and flipped signs. So that gives me my next 2. This one I multiplied by a -3/2, which gave me those 2 next terms. So hopefully we're starting to get more used to these sequences and finding their patterns. Now there's 2 ways that we write formulas for these sequences, these patterns. We can write a recursive formula, which defines each new term by 1 or more of its previous terms, versus we could write an explicit formula that describes how to find any term in the sequence. In general, your explicit formula is going to be more helpful because, let me give you an example. Let's say I wanted to find the 100th term in a sequence. If I only have a recursive formula, I need to find all the previous terms to find the 100th term. So I need 1 through 99 before I can find 100. If you have an explicit formula, you can just plug 100 into that formula and it will give you the 100th term, any term. So in general, explicit is more helpful than recursive, but throughout today's lesson, we will talk about how to find both. A couple more vocab terms. If you see this a sub n, that means the nth term of the sequence. Basically, that means the equation for the sequence. So like if I wanted to say a sub n equals 3n minus 5. That's the equation for this sequence, and I plug in my term number to get my answer for that term. So if I wanted to say the first term, a sub 1, that would be 3 times 1 minus 5, which would be -2. So the first term of my sequence is -2. This would be a good example of an explicit formula. I could plug in any term into this formula, and it gives me the answer for that term. We also have this, which is, we pronounce it A0, is how it's pronounced. That is your starting term. We also sometimes refer to that as A1 as your starting term, depending on if you're starting with 0 and 1 in the sequence. Last few things, just a little more about our recursive formula. We must know the previous terms to find the new term. So if we wanted to find, like I said, the 101st term, we would need to know all the 100 terms before it in order to find the next one. The better way to do that is the explicit formula, which just gives us a general formula that works that I can plug anything into. So that is all our big vocabulary for this lesson, talking about introducing sequences and the different formulas we have for them. In the next video, we're going to talk about how to graph sequences.